So the square root of 3 divided by the square root of 27. I basically want to simplify that, or write a better notation of that. We are dividing two radicals here, and the first step to doing this, I see, to kind of cleaning it up, would be to make it put together into one radical. Can you see? I can push it back into one radical and call that 3/27. Then can you reduce the fraction? Hopefully you can see I can reduce that as 1/9. All right? So you might go, how does that help? Well, can I break it up into two radicals again? So I'm kind of doing like an accordion. I kind of put it together. Now I'm going to take it back apart. Because sometimes putting it together lets you reduce. You couldn't really reduce maybe very easily. So I put it together so I can reduce. Now I take it back apart, and I'm to here. And from there, can you easily see the square root of 1 is 1, and the square root of 9 is 3. Now, some of you could have jumped straight here if you kind of can think through it and understand what's happening, but I try to show the steps. We brought it together, reduced, took it back apart, and got an answer. For this next one, I can't put it together because one is not in a radical and one is in a radical, so you can't do this first property. But there is something interesting about radicals. There's an unspoken rule or it kind of is a simplification rule technically, maybe it's not unspoken. But you're not supposed to have radicals in the denominator. It's just simplified way, it's like taboo. So we have to find a way to get rid of the square root of 7 out of the denominator. And in order to get the square root out of the denominator, what we do, it hopefully makes some sense, but can you just multiply the square root of 7 times top and bottom? Because isn't that multiplying by 1? It's just a weird looking 1. And when I do that, watch what happens. You end up with 5 times the square root of 7 on top and the square root of 49 on bottom. Do you see why I chose square root of 7? Some of you see it maybe? Because the top is still 5 square root 7, but the bottom, what's the square root of 49? It's 7. Do you see how the square root is not in the bottom anymore? And we just simplified it. It's interesting. You're basically trying to get all square roots out of the bottom. It's just a common way to write it. So you will never see on a multiple choice test, rarely see a square root on the bottom. So you have to be able to change it so it kind of moves to the top. And by the way, does 5/7 reduce? No. If that was like 5/10, you reduce it. But it's not, so you're done. So that right there is my new version or equivalent version to this. And this is a more commonly written answer for that. So for this last one, well, first thing I want to do is, can I just simply reduce that fraction? And you notice, oh, you can. So let's just do that real quick. That becomes the radical of, what goes into 8 and 10? Isn't that 4/5? Now, okay, now let's just think, okay, 4/5. Well, isn't the square root of 4 something nice? That's a nice clean up there. So watch this. I'm going to make that the square root of 4 times the square root of 5, because you're allowed to break that up into two square roots, which that leaves you with the square root of 4 is 2, and the radical 5 just stays. All right, but now, after doing all that, now doesn't this look like this? And aren't we supposed to get rid of square roots in the denominator? So now we have to do a little bit more simplification. So how do we get rid of that square root of 5 on the bottom? Well, we multiply top and bottom by the square root of 5. Because what you get when you multiply by the square root of 5, on the top you just get that. But on the bottom, don't you get the square root of 25? Which ends up becoming 5. So you end up with 2 square root of 5 over the square root of 25 is 5. And 2/5 does not reduce. Do not try to cancel these. You can't cancel a radical with a non-radical. But the 2/5 is not reduced. That is my final answer. So if you started with this, you'd probably see a final answer that looks like this. We're just learning to rewrite them in different notations, and this is kind of a simplified version, if you want to call it that.